The impacts of hormonal birth control use. Who am I? My name is Rachel Huerena. I'm a medical laboratory technician certified with the American Society for Clinical Pathology. I'm graduating this year from Winston-Salem State University with my bachelor's in medical laboratory science. Today I'm presenting a summary of the research paper that I wrote on the impacts of hormonal birth control. Why I picked my topic. I decided to research the impacts of hormonal birth control on its users after listening to the testimonies of my peers. I work with a staff of mainly women, and many of them have been using hormonal birth control for an extended period. They have told me the different ways that they believe hormonal birth control has impacted them. This made me wonder if there were any scientific evidence behind their claims. I decided to start researching how hormonal birth control use impacts the users. I started my research by looking into the mechanics of ovulation and how hormonal birth control works to prevent pregnancy. I found that at the beginning of the women's cycle, estrogen and progesterone are low, which triggers the pituitary gland to produce follicle-stimulating hormone and luteinizing hormone. Next comes the follicular phase, where the rise in FSH levels stimulates the ovaries, causing estrogen and progesterone production, creating a spike in LH, and leads to follicles in the ovaries to mature. The next step of the cycle is ovulation, where there is a spike in estrogen levels, FSH reaches a peak, and LH continues to climb, leading to a follicle releasing an egg to the fallopian tubes. The empty follicle continues to produce estrogen and progesterone. The increasing progesterone levels cause the lining of the uterus to thicken. 12 to 24 hours after ovulation, if a pregnancy has not occurred, then the empty follicle stops producing hormones. Estrogen and progesterone drop, and a woman's period starts. Hormonal birth control works to prevent unwanted pregnancies by preventing ovulation by keeping progesterone levels slightly elevated to mimic the levels after ovulation. Without the decrease in progesterone levels, then FSH and LH will not increase, which stops the signal to the follicle to mature and releasing an egg, therefore preventing ovulation from occurring. What I discovered. Through my research, I discovered that the long-term use of hormonal birth control is associated with alterations in endocrine function by suppressing natural hormone cycles, influencing metabolic processes, and changing stress responses. Hormonal birth control use suppresses natural hormone cycles by decreasing the user's pituitary hormones and ovarian hormones due to the synthetic hormones found in the hormonal birth control. I also saw that anti-Mullerian hormone and anterior follicle count are also diminished by hormonal birth control, but they can return to normal levels after 2 months of discontinuation. Long-term hormonal birth control use may result in profound ovarian suppression that leads to a diminished ovarian reserve. The hormonal birth control use can influence metabolic processes when administered orally. It causes an increase in production of VLDL and HDL while decreasing LDL due to the synthetic estrogen present. Increased VLDL can be a sign of metabolic disorders. The progesterone in hormonal birth control influences insulin secretion, insulin half-life, and glucose tolerance, with androgenic progesterone increasing insulin secretion and worsening glucose tolerance. Hormonal birth control can change the stress response of the users in many different ways. Hormonal birth control users appear to have a higher perceived chronic stress in research studies utilizing self-reported perceived stress scale scores. Altered hormonal signaling caused by hormonal birth control leads to HPA axis dysregulation. The synthetic hormones that are used in hormonal birth control lead to altered hormone signaling that may suppress normal HPG cycling and ovulatory spikes that help regulate stress by interacting with brain systems. Suggestions for future research. The research regarding the suppression of natural hormone cycles and its impact on the ovaries is limited by the individual cycles and general reproductive health for each test subject. The variety of androgenic activity of progestin and the impact of the dosage of the hormonal birth control does not allow the researchers to pinpoint the metabolic impact of estrogen. The research on the carbohydrate metabolism was less extensive and was limited to insulin response, glucose tolerance, and insulin half-life. This leaves gaps in the overall understanding on the impact hormonal birth control has on glucose regulation. The research study regarding the impact of hormonal birth control use on stress responses stated that their cortisol findings were trends and therefore could not be considered definitive proof. The study also only utilized pre- and post-saliva cortisol samples instead of a full-time series of cortisol curves, which could have an impact on the results. More extensive and controlled research is required to fully understand the impact that hormonal birth control has on the metabolic process and stress responses of its users, and to prove that hormonal birth control is the direct cause of metabolic and stress response issues. Overall, the research regarding the impact hormonal birth control has on its users needs to improve by verifying the user's typical cycles and grouping them into similar groups to see how the birth control impacts different menstrual cycles. Eliminating test subjects that have other factors that may impact test results, such as menstrual issues like ovarian cysts, and conducting different studies for the various forms and dosage of hormonal birth control due to the different impacts the different types of synthetic hormones and different dosage amounts have on the users. Personal realizations. While I was completing my literary review for my research paper, I was surprised to see how there was not as many experiments done to find the lasting impacts hormonal birth control has on its users as I had anticipated. Hormonal birth control is a very common form of contraceptive, so I had anticipated that there would be plenty of resources for me to use for my paper. Instead, I was surprised to see how there were more literary reviews on the topic than actual experiments studying the impacts of hormonal birth control. The impacts hormonal birth control had on the stress responses of its users also surprised me. I did not realize that hormonal birth control had an impact on the mechanisms responsible for certain stress responses. Conclusion. The long-term use of hormonal birth control is associated with alterations in endocrine function by suppressing natural hormone cycles, influencing metabolic processes, and changing stress responses. But current research requires more thorough evidence due to the complexity of these individualistic effects of long-term hormonal birth control use. Hormonal birth control is one of the most used forms of contraceptives, but there are many different forms, including different dosage amounts, different synthetic hormone types, and different routes of administration. In addition to the various hormonal birth control forms, many studies that were conducted were working with the same limitation, that each woman may have a different cycle than what is considered the norm. This makes it harder to pinpoint if long-term hormonal birth control use is truly the cause of their diminished ovarian function and reserve, changes in stress response, or changes in metabolic processes. While evidence points to long-term hormonal birth control being a major influence in these side effects, more research is required to learn the long-term impacts of each form of hormonal birth control and to establish different ranges of normal menstrual cycles of various groups of women and how hormonal birth control impacts them.